Hey there, science fans! Have you ever seen something that seemed to defy gravity? Today, we're diving into a captivating world where physics takes center stage. Imagine this, a ball placed on a tilted surface, seemingly on the verge of tumbling down. But wait, instead of succumbing to gravity's pull, it embarks on an unexpected journey, moving gracefully without ever falling off. Let's dive right in! In our quest to understand the non-falling ball, we'll break down the experiment into bite-sized pieces. First, we'll introduce you to the scientific concepts that hold the key to this gravity-defying act. Next, we'll guide you through setting up your very own non-falling ball experiment. Get ready to witness the captivating interplay of forces as we observe the ball's mesmerizing dance on the inclined plane. All right, science sleuths, let's get to the bottom of this non-falling ball mystery. Our mission today, to figure out why a spinning ball perched precariously on a slope defies gravity. This seemingly simple experiment opens a window into the fascinating world of forces and how they interact. By carefully setting our experiment in motion, we'll see how different factors, like the ball's spin and the angle of the slope, play a crucial role. So, get ready to put on your thinking caps and embrace your inner scientist. Hold on tight, because we're about to delve into the heart of the matter centripetal force. Imagine swinging a ball tied to a string in a circle. Notice how the string constantly pulls the ball inward. That's centripetal force in action. In our non-falling ball experiment, the sloped surface acts like the string, providing the necessary inward force to guide the ball along its curved path. The faster the ball spins, the stronger the centripetal force needs to be to keep it on track. But wait, there's more to this physics puzzle. Centripetal force isn't the only player in town. We're dealing with a ball on a slope, which means gravity is constantly trying to pull it down the incline. The answer lies in equilibrium, a state where all the forces acting on an object are perfectly balanced. On one side, we have gravity pulling the ball downwards. On the other side, we have the normal force from the surface pushing back against the ball. In our experiment, friction acts as a crucial stabilizing force, preventing the ball from sliding sideways. All right, science enthusiasts, let's gather our tools. To bring our non-falling ball experiment to life, we'll need a few key ingredients. First on our list is an inclined plane, our stage for this gravity-defying act. You can use a variety of materials for this, like a smooth wooden plank or a sturdy piece of cardboard. Next up, we need our star performer, the ball itself. The choice of ball can influence the experiment's outcome. Lastly, we'll need something to prop up our inclined plane and create that crucial angle. The ability to adjust the height of the incline will allow us to experiment with different angles and observe their impact on the ball's behavior. With our materials assembled, it's time to set the stage for our non-falling ball spectacle. The surface should be smooth and free of any bumps or obstacles that could interfere with the ball's roll. For added stability, you can place a non-slip mat or a piece of rubber shelf liner underneath the inclined plane. Use your stack of books, box, or designated assistant to prop up one end of the inclined plane, creating a gentle slope. Finding the sweet spot where the forces are in equilibrium will be key to witnessing the non-falling ball phenomenon. Now let's talk about our star performer, the ball. Choosing the right ball can significantly impact the outcome of our experiment. Ideally, we want a ball that is dense and heavy enough to resist external forces. The size of the ball can also play a role. A larger ball will have a larger surface area in contact with the inclined plane. The material of the ball is another factor to consider. A smooth, hard ball will experience less friction. Ultimately, the best way to find the perfect ball is to experiment with different options. Gather a variety of balls you have around the house and see how they behave on the inclined plane. All right, science aficionados, the moment we've all been waiting for has arrived. Gently place the ball at the top of the inclined plane, holding it steady with your hand. With a gentle flick of your wrist, impart a spin to the ball as you release it onto the inclined plane. The direction of the spin is important. We want the ball to spin sideways, perpendicular to the direction of the slope. As you release the ball, observe its motion carefully. If all goes according to plan, you should witness a captivating sight. The ball curving along the inclined plane, seemingly defying gravity's pull. Keep a close eye on the ball's motion. Notice how its spin affects its path. The sideways spin, combined with the ball's forward momentum, creates a difference in air pressure on either side of the ball. This pressure difference, known as the Magnus effect, generates a force perpendicular to both the spin axis and the direction of motion. Finding the right balance between the incline's angle and the ball's spin is key to observing the non-falling phenomenon. Don't be afraid to experiment. Try releasing the ball with different amounts of spin. Now, let's fine-tune our experiment and find that sweet spot where the forces are in perfect harmony. Start by adjusting the incline's angle. If the ball is consistently rolling off the side, try decreasing the angle. Conversely, if the ball seems to be struggling to maintain its curve, try increasing the incline's angle slightly. As you adjust the incline, pay close attention to the ball's spin. If you're finding it challenging to impart enough spin, try using a spinning toy to give the ball a more consistent spin. Now that we've mastered the basics, let's get creative and explore some variations. Experiment with different surfaces for our inclined plane. What happens if we swap out the smooth wooden plank for a piece of sandpaper? Another intriguing twist is to introduce obstacles along the ball's path. How does the ball's trajectory change as it encounters these obstacles? Don't be afraid to think outside the box. You can even experiment with using multiple balls simultaneously. The possibilities for exploration are endless. Section 5, Troubleshooting Tips, What to Do when Gravity Strikes Back. Even the most carefully crafted experiments can sometimes hit a snag. If you're finding that your non-falling ball is being a bit too obedient to gravity's call, don't despair. Here are a few troubleshooting tips to help you get back on track and witness the magic of physics in action. First, double-check your setup. Is the inclined plane smooth and free of any bumps or obstacles that could be throwing the ball off course? Is the angle of inclination appropriate for the ball's spin? Remember, a steeper incline requires a faster spin to generate enough lift. Next, examine your ball. Is it smooth and round, or are there any imperfections that could be affecting its spin? A dented or misshapen ball might not roll as smoothly, making it harder for it to maintain its curved path. If possible, try using a different ball to see if that makes a difference. Finally, don't underestimate the importance of practice. Imparting the right amount of spin to the ball takes a bit of finesse. Try experimenting with different hand positions and release techniques until you find what works best for you. Remember, science is a journey of discovery, and sometimes the most rewarding moments come after a bit of trial and error. Witnessing the wonders key observations from our experiment. Wow, what a ride! We've spun, we've observed, we've tweaked, and we've learned. Let's recap the amazing observations from our non-falling ball adventure. Remember when we released the ball and it took that captivating curved path? That was the magic of physics in action. We saw centripetal force pulling the ball towards the center of its path. Spin played a crucial role in this gravity-defying act. The faster the spin, the tighter the curve, resisting gravity. Like a spinning top, the ball found its balance, staying aloft. It was a delicate dance of forces, showcasing the elegance of physics. Section 2. Connecting the dots, how our findings reveal physics in action. Now, our journey doesn't end with simply observing these cool phenomena. The real excitement lies in understanding the why behind the wow. Let's connect the dots between our observations and the fundamental principles of physics that govern this captivating experiment. At the heart of the non-falling ball experiment lies the concept of centripetal force, the force that acts on an object moving in a circular path, constantly pulling it towards the center. In our case, this force arose from the interaction between the ball's inertia, its tendency to move in a straight line, and the inclined plane's normal force, the force pushing back against the ball perpendicular to the surface. The ball's spin added another layer of complexity, introducing us to the Magnus effect. This fascinating phenomenon occurs when a spinning object, like our ball, disrupts the flow of air around it, creating a pressure difference. This pressure difference generates a force perpendicular to both the spin axis and the direction of motion, causing the ball to curve. And let's not forget about friction, the unsung hero that played a crucial role in keeping our ball from simply sliding down the incline. Friction provided the necessary grip, allowing the ball to roll smoothly and maintain its spin, ultimately contributing to the success of our experiment. Section 3. Beyond the ball, real-world applications and everyday connections. So, we've explored the science behind the non-falling ball, but you might be wondering, what's next? How does this relate to the real world? Well, the beauty of physics is that its principles are all around us, shaping the world we live in, from the simplest everyday occurrences to the most complex technological advancements. Remember that curveball a baseball pitcher throws? That's the Magnus effect at play, just like in our experiment. The spin of the ball creates a pressure difference, causing it to curve downwards, much to the dismay of the batter. And what about those massive airplanes soaring through the sky? They rely on a similar principle of lift, generated by the shape of their wings and the flow of air over and under them. By manipulating these forces, engineers have designed aircraft that can defy gravity and transport us across continents. From the way cars navigate curves to the design of roller coasters that keep us safely thrilled, the principles we've explored in our non-falling ball experiment are woven into the fabric of our world. So keep exploring, keep questioning, and keep that scientific spark alive, because there's a world of wonder waiting to be discovered. Section 1. That's a wrap. Celebrating the thrill of scientific discovery. And there you have it, science explorers. We've journeyed into the heart of physics, unraveling the mysteries of the non-falling ball experiment. Remember that feeling of awe when you first witnessed the ball defying gravity's pull? That's the magic of science, igniting our curiosity and revealing hidden wonders. We've learned about the invisible forces that govern our universe, but most importantly, we've experienced the thrill of scientific discovery. Science is about asking questions, seeking answers, and embracing the unknown. It's about looking at the world with wonder and creativity. Appreciate the intricate dance of physics at play in everyday wonders. Section 2. Keep the curiosity burning, the adventure continues. But our journey doesn't end here, science adventurers. The world is brimming with fascinating phenomena waiting to be explored. Every question we answer opens the door to countless more, each more intriguing than the last. So keep that scientific spirit alive, keep asking why, and never stop exploring the wonders of the universe. If you enjoyed our non-falling ball experiment, be sure to hit that subscribe button and join our community of science enthusiasts. We've got a treasure trove of exciting experiments, mind-boggling demonstrations, and thought-provoking discussions lined up just for you. From the depths of the ocean to the vastness of space, from the tiniest subatomic particles to the grandest galaxies, there's always something new to discover. So, grab your lab coats, put on your thinking caps, and get ready for more science adventures with us. Until next time, stay curious, keep exploring, and never stop believing in the power of science to inspire, amaze, and change the world.